All right, so this section's about numbers and calculations, partly about rounding, and then also just about some stuff about estimation. So decimal notation, that allows us to write numbers to a chosen degree of accuracy. So you can give something to a certain amount of decimal places, whatever the accuracy is that you want to do. Sometimes we limit our accuracy to which we write our answer because of limitations with our original data. So for example, if you have a table that you measure in 185 centimeters, we only have 3 digits of accuracy there. We're not going to want to try to go for more accuracy than that. Now, when you're talking about significant figures, that has to do with your accuracy. Leading zeros that are after a decimal point, so you have the decimal point and then a bunch of zeros and then a number. Those bunch of zeros don't count. It's just a place marker for your decimal places. If you have any zeros at the end of a big number, let's say, so you've got, let's say, 1 million. The 1 is the only number that is significant in that situation. I personally have a hard time with that, but I'm not the one that came up with this idea. So if you are given answers, if you're asked to give 2 DP, that means decimal places. If you're asked to give 2 SF, that means 2 significant figures. So just a couple examples. I know I'm a little rusty on my significant figures. So for A there, 0.00023. Again, those leading zeros there don't count. So my only significant figures would be 2 and 3. And so this number has 2 significant figures. Okay. Now the next one, I've got a bunch of zeros, but in this case, all of this.
Dr. Belker, please call Alan Head. Dr. Belker, please call Alan Head.
Okay. All of that is what is considering counting. So the zeros in this case at the end do count because it's in a decimal. If this was not a decimal, then the zeros at the end would not count. So in this case, my significant digits are 5, 0, 4, 0, and 0. So this number has 5 significant figures. Okay. Next, these are my numbers that would be considered significant. The zeros at the end do not count, but the 0 that's in between the 1 and the 2 do count. So 1, 0, 2, 3 significant figures. Okay. Next, I'm not sure why I don't have a comma in my question there. Normally, I'm a pretty big stickler for commas. In this case, those are the only digits that count. 1, 2, 5, and 2. So 4 significant figures. On my paper, I've got something different. Hold on just a second. Okay, very good. Okay, last one here. Again, we've got several zeros. In this case, these zeros are all counting because they're in between other numbers. The 0 here at the end counts because it's in a decimal. So in this case, all the digits a little sloppy there, sorry. All the digits in this number are significant, so we have 3, 4, 5, 6, 7 significant figures. All right, so next, calculate. We're going to give the answer exactly, which means no rounding whatsoever, correctly to 2 decimal places, and then correct to 3 significant figures. So when you type that in your calculator, and this would not be something you would need to show work for, just type it in all in one step exactly the way that it looks. My exact answer ends up being 94.191. And that's, again, all the decimals, that's everything. Now, correct to 2 decimal places. Those would be my 2 decimal places. So looking at that 3rd decimal place to decide what I need to do with the 9. Since there's a 1 at the end, that 1's going to make the 9 stay the same. So 94.19. It is important to note that this last number here in that decimal place, don't just make it a 9. Look to see, do I keep it a 9? Am I going to have to round it up? Now, correct to 3 significant figures, that's going to be 94 point. Okay, so now we're looking at the 1. There's a 9 that comes after the 1, so the 1's going to go up to a 2. So pay attention. You might be asked to do things in decimal places as opposed to sig figs. right, and then the last thing here, we're going to talk about accuracy and range of values. So this is something that in your book, it does it a little bit different than what I've seen other places, and so I'm not sure exactly which way to go about it here. So I'm going to go about it the way that I feel like you would be given on the exam. So when you do a measurement, your measurement is accurate to positive, negative, 1/2 at the smallest division on the scale. So that's kind of easier to explain in an example. So Rod uses a tape measure that has graduations in centimeters to measure his height. So that means it's broken up into centimeters. What is Rod's height range if he estimates his height to be 188 centimeters? So an estimate, that's going to kind of be, you've rounded. So that could have been 1/2 centimeter less than that and rounded to 188, or it could have been 1/2 centimeter almost more than that and rounded down to 188. So essentially we've got 188 plus or minus 1/2 centimeter. So as far as how I would give that as my answer, if I go down 1/2 centimeter, 187.5, that would round up to 188. That would be less than or equal to H is less than 188.5. Now, the upper range does not include 188.5 because if my height was 188.5 and I were estimating it, I would round that up to 189. And I want it to be 188. So it can be super close to 188.5, but it would need to round down. So now, this is what is different in the book. Your book doesn't necessarily talk about that final measurement there needing to be just a less than. But it needs to be. So, okay. Now, last part here has to do with finding error in measurement. Now, we looked at this earlier in the year, or maybe not, depending on who's watching this video. But anyways, that error, which is a Greek letter, I think, epsilon, looks like. In a measurement or calculation, you're going to use the following formula. This is in your formula booklet. So you have the absolute value of V sub A minus V sub B over V sub B times 100%. Now your V sub B is the exact value, and the V sub A is the approximate value. Now if you leave the absolute value off, that'll tell you whether you're high or low. With the absolute value, it just tells you in general what the error is. So we have a piece of ground that is in the shape of a rectangle measured to the nearest meter. Its length is 12 meters and its width is 6 meters. So write the possible values of the length in the form A is less than or equal to length is less than B. Okay, for the length right now is 12. So as far as my range, that's going to be 11.5 less than or equal to L is less than 12.5. Again, it can't really be 12.5, but it can be close to that. For my width is 6, so that's going to be 5.5. W is less than 6.5. Okay. Now calculate the minimum possible perimeter of the rectangle. Well, the minimum would be if all of the lengths were the least that they could be. So I can have 11.5, 11.5, 5.5, and 5.5. Of course, perimeter of a rectangle, you need to add each side of your rectangle there, which is going to have double dimensions for your length and width. And that's going to give me 34. So that's the least that the perimeter could actually be. Now, what if we use that 34, okay? That's an estimate. What if we know that if we use the given measurements as is, and we end up with a 36. Let's say that actually is the legit perimeter. So what kind of error would we be if we use the lower end, though, of that perimeter? So we're going to make our V sub E be 34, and we're going to let our V sub A be 36. And actually, it looks like here, I want the minimum to be, oh, yes, if I read the directions of my question, assume that the rectangle had the minimum possible perimeter. So that is our exact perimeter. But if I use those rounded measurements up in the example, the very beginning of the problem, then that means that my estimated value, approximate value, would be 36 centimeters. So in my formula here, I'm going to take my 36 minus 34 over 34. Now again, that formula is given to you like that, so you'll know how to plug things in. And it does actually even say the V sub B is the exact and the V sub A is the approximate, so you don't have to remember which one is which. So if I do the math here, I get 2 over 34. Don't worry about reducing that. Just go ahead and make it a decimal. As a decimal, that's going to be 0.0588-ish. Keeps on going there. Times 100 means I have 5.88%. Now, this would be actually a positive 5.88%. If we take off the absolute value, I do end up with a positive number to begin with. If it was vice versa, the other way around, then I would be below 5.88%. Okay, so that's it. As always, if you see something that I didn't talk about, look at the solutions. Those are all in Google Classroom. Otherwise, if you have a question, though, let me know.